Hello guys, welcome back to the channel. Today we are going to continue with the Databricks series. I know we have already covered some of these topics before, but as we mentioned, we are following the plan to cover most of the things they do in the Databricks Academy. One more time, we will go through the concept of how to promote data from the bronze layer to the silver layer and then subsequently to the gold layer. Although these are the standard guidelines we need to follow, it does not mean it always works like that, especially when it comes to complicated real-life scenarios you are facing at work. In tutorials, we are using simple examples, so it's easier to explain the basic things. Based on this knowledge, then you can apply your own thinking and flavor on your code. Let's see again briefly what the slides say about the silver and gold layer, and then we will move to our Databricks workspace. Here we are again, we have the bronze layer that represents the unprocessed history of the data. Essentially, we capture the provenance of the data that is being loaded into the lakehouse. We don't parse the data, we don't make any changes. Essentially, we dump the data in the bronze layer as it comes. It's append only, so whether it's batch or streaming, it doesn't matter. We just append the data and we try to keep as many records as possible, because if something happens downstream, then we can come back to the bronze layer, get the data, etc, etc. Now the silver layer preserves the grain of the original data without any aggregations. What we are trying to do here is to eliminate duplicate records, enforce the schema if possible, perform data quality checks, quarantine corrupt data, and in general build our data model on the silver layer. And the gold layer is where we have our star schemas and the data marts, so that the business analysts and the data scientists can query the data. Okay guys, once again we are going to use the Raspberry Pi simulator provided by Microsoft, and here we have already set up an IoT hub on Azure that will be receiving streaming data from this IoT simulator. So I have already provided the connection string, as you can see here. I click run and we'll start sending data to our IoT hub, right? So message 1, message 2, device 1, temperature, humidity, wind speed, wind direction, RPM, angle, etc, etc. So all this data, we are receiving all this data into our IoT hub. As you can see, there is a spike here, meaning that we started receiving data already. Now, in our Databricks environment, I have already created a notebook. Actually, it's the same that we used in the previous video to read from the IoT hub and store the data into the bronze table. We have a table called bronze IoT. So we need to create a Delta Live table pipeline in order for this to be executed. So let's go into Delta Live tables, create a pipeline, test, DLT, whatever, advanced, triggered, yeah, and then select your notebook, Hive Metastore, target schema, example, perfect, cluster policy, we don't need that, minimum workers 0, maximum workers 0, and yep, click on create, and then we can start our Delta Live table pipeline that will start inserting records, streaming data from our IoT hub into our bronze table on Databricks. Let's wait for it. Will take a few minutes, so be patient with that. Unfortunately guys, I cannot run the Delta Live table pipeline because I have already reached the quota. I am using a free trial account apparently, so there is a limit, but it doesn't really matter because we have done the same example before and I have already ingested the data, and the purpose of this video is not to get data, to ingest data from the IoT hub. We have seen that before. It's just to move data from the bronze layer to the silver layer and to the gold layer. Now let's see the data we have on the bronze layer. We have the message ID, device, temperature, RPM, angle, timestamp, etc., etc. So we have all this good data, 31 records. And here, what we need to do is to perform a streaming deduplication. Structured streaming provides exactly one processing guarantees. However, many source systems will send duplicate records, of course. We need to identify and drop the duplicates in streaming data. We can use watermarking to manage the state information, and we have to write an insert-only merge statement to prevent inserted duplicate records into the delta table using a for each batch to perform a streaming upsert. So essentially, we need to dedupe the data, the streaming data, as the data comes, and then also write a merge statement, because maybe there is this record, the record with the same ID already exists in the data, in the database. So we, using a merge statement, we can create an upsert, and then we will not have any issues at all. So this is our original data. Now if we group by device ID, we can see that we have duplicates based on the device ID. So as you can see, device 1 has 6 records, device 3 has 5 records, etc., etc. We have plenty of duplicates. So if we filter for device ID 2 and we drop the duplicates, then we shouldn't have duplicates for this device ID. We should only get one record. Apparently, this way, when we drop the duplicates, we don't know which record we maintain, right? So we drop the duplicates and we keep only one record, and we haven't defined any logic here which record to actually keep, which is very important in real case scenarios, right? But because we're going to make this example simple, we just use drop duplicates in the streaming data. Then let's dedupe all the data based on the device ID. So from 30 something records, we have up here 31 records. We went down to 6 records, only one record for each device ID, right? Perfect. We are choosing to apply deduplication at the silver layer rather than the bronze layer. The reason is our bronze table retains a history of the true state of our streaming source. This allows us to recreate any state of our downstream system if necessary and prevents potential data loss due to overly strict quality enforcement. Define a streaming read on the bronze. When dealing with streaming deduplication, we need to ensure that in each microbatch, no duplicate records exist in the microbatch. That's why we dedupe the data, and records to be inserted are not already in the target table, and if they are, that's why we are using a merge statement. Spark structure streaming can track state information to ensure that duplicate records do not exist within or between microbatches. Applying a watermark of appropriate duration allows us to only track state information for a window of time in which we reasonably expect records could be delayed. So if we dedupe the data again using watermark, timestamp 10 seconds, and then drop duplicate, as you can see, this is now initialize the stream. And let's move on until this one is finished. Insert only merge. Delta Lake has optimized functionality for insert only merges. This operation is ideal for deduplication. Define logic to match on unique keys and only insert those records for keys that do not already exist. So, okay, perfect. This streaming job provided results here, and as you can see, again we have 6 records because we have dropped the duplicates, right, based on ID. Perfect. But this time is it's a streaming job, right? So let's cancel this one, and here let's create a silver table. Now an easy way to do that is actually use this show create table example.bronze, which actually provides the DDL statement of the bronze table, and then you can copy this one so you don't have to rewrite everything. And this is what I've done. If we move here, so we create a silver table, and then using for each batch we are going to use a merge statement and actually read streaming data from the bronze layer using watermark. We drop the duplicates, and then in the write stream, when we write to the target table, we use the for each batch, the upsert query, the output mode update option, the checkpoint location, trigger once, true, and dot start. And this is how we can do all these things. Below I have the definition of the upsert query, and here we have our function upsert query function. We pass the data frame and the batch ID, and here the data frame we save it as a temporary view called bronze layer, and using the bronze layer as a source, then we merge the data into the serial table based on device ID. If the device ID doesn't match between the source and the target, then we insert all the records in the target. Let me run this command here, and then let me run this command as well. And in theory it should start streaming data from the bronze layer using with watermark. We use the timestamp column 10 seconds here. We drop the duplicates based on the device ID, and then using the for each batch method and performing our merge query, we are going to store the data into the serial table. Okay, it finished, so let's get the data from the silver table here. We have 6 records, right, because we deduplicated the data as it came here when we started streaming. Perfect. Now another thing I want to mention, so let's truncate this table, the serial table, and then let's insert into the bronze table, let's insert another, let's put here 9, 9, 9, 9, 9. That's fine, the timestamp. So let's insert a new record to the bronze table and then rerun the code above. So let's rerun this code here. Let's see what happens. In theory, this new record has a ID that doesn't already exist in the target table, right? Because it's actually I didn't need to truncate the table. That was a mistake from my part. Let's see the data again. Now we have 9, right? So, and the reason is when I truncated the data here in the checkpoint location, we keep the state of the data. So when I truncated the data, but in the checkpoint, this data has already been loaded. So we only load the new data, right? I think I should rerun this example using a different checkpoint location, so to start from the beginning. So let's say test, right? So this, now let's truncate again the serial table. Now it's empty. Let's rerun this query with a different checkpoint location, so it should get all the data from the beginning. We should get the deduplicated data from the beginning. So let's see, we expect 7 records this time because we added a record before to the bronze layer with device ID 9. So we expect to see that. So 7 records, device ID 9. Perfect. Now the thing is, so here we insert, let's insert another one with device ID 10, right? 10, etc, etc. So let's do that and rerun the code, and it should only insert the last record that we inserted on the bronze layer. Okay, so it's done. Let's see what we have here. So we should have one more record now, right? Eight records with ID 10 here. Perfect. So when we insert data to the bronze layer and then we run this code, everything is fine because we just append data on the bronze layer. But remember, we are using streaming, structure streaming. That means if we update the data on the bronze layer or we delete the data on the bronze layer, this query here, this code here will give us an error. And I will prove that to you right now. So update, let's update a record for device ID 10. Let's change the temperature to, I don't know, like 54, right? Let's update this record on the bronze table. But now that we will run, as you can see, it affected one record. So if I run this code again, it will give an error. And this error will be because we performed an update on the source data. As you can see, it says detected a data update in the source table at version 8. This is currently not supported. If you would like to ignore updates, set the skip change commits to true. If you would like the data update to be reflected, please restart this query with a fresh checkpoint directory. So if I just change the checkpoint location here to a new one, we can reload the data again and again, but that doesn't really make much sense, to be honest. So here we have this option where it says skip change commit. So whether the updates that we perform or the deletes that we perform on the bronze table don't get propagated to the silver table, right? So no matter how many times you run the code, it ignores updates and deletes. So on the serial table, you will not see any changes. So this is something to bear in mind. We can ignore the updates and deletes so our pipeline doesn't break. Moving on, we have the quality enforcement. Now we can add additional quality checks that can be helpful to ensure that only data that meets our expectations makes it to the lakehouse, to the silver layer. We can add check constraints to delta tables and describe and implement a quarantine table. Now let's see what tables we have. Okay, we have plenty of tables here. But let's describe the bronze table, right? See what we have here. We have the data types, catalog, database, table name, created, external, blah blah blah, all these cool things, and table properties here, change data feed, owner. Okay, so now if we can add a constraint, right, like a database, alter table, table name, add constraint, the constraint name, check that RPM is greater than 0. As you can see, that was fine because in the data every value in the RPM column is greater than 0. But of course, let's describe again the table and we will see the constraint because it's mentioned. Table constraints, as you can see, we have the constraint here. But what happens if the condition of the constraint isn't met, right? What happens in this case? So we cannot, apparently we cannot apply the constraint then. So for example, if we use angle greater than 100, it fails because 33 records violate the constraint. How can we deal with this? We could manually delete the records and then set the check constraint or set the check constraint before processing the data from the bronze table. However, if we set a check constraint and a batch of data contains records that violates it, the job will fail and we will throw an error. If our goal is to identify bad records, but keep streaming jobs running, we will need a different solution. We can quarantine the invalid records. Okay, so we can drop this constraint if doesn't really matter. So the thing here is how we can quarantine the records. We just use a separate location. The good records go, here. The bad records go there in a different destination. It's pretty simple. Here you can use a new table with the same schema, and let's select the data from the bronze table here and store it into a data frame, and then truncate the silver table and the RPM quarantine table. And in the next step, what we can do is actually using filter the data frame with the criteria we want. Here is like less and equal than 50, and here should be greater than 50. So if it less equals than 50, then we can append the data. It's valid. The data is valid, and we can append the data into the silver table. Otherwise, it goes to the second table, the RPM quarantine table, that we store the broken records or the records we don't want. Yep, and here we can see the data from the quarantine table that actually validate. We have applied this criteria here. RPM greater than 50, everything is greater than 50 here, and on the zero table everything should be less than 50. Yep, perfect. Another way to do things here is to use flags to avoid multiple writes and managing multiple tables. We can choose to use the flagging system to warn about violations while avoiding job failures. It has a little overhead. Basically, it's a case when statement. So when the RPM column is greater and equals to 50, then just use this, display this one. Otherwise, it's less than 50, and we create a new column called RPM underscore check, and we can also drop the duplicates. But the main point here is we can use a case when statement, create a flag, and if this record is valid, then in the flag we provide 1, or if this record is not valid, then we use 0 or something like that. You can customize your flags apparently. And here, if we scroll to the right, you can see the new flag column, which describes the records. Moving on to the gold layer, here we can use views or materialized views. What's the difference? Stored views differ from data frames and temporary views by persisting to a database. Views register the logic required to calculate the results, which will be evaluated when the query is executed. The query always uses the latest version of its data source. This is how you can create a view here. A typical view, create or replace view, the view name, temperature. You can provide comments for the columns and comment for the view. As select, and you provide the select query that you want in order to form the view. Right here we select from the bronze table where device ID greater than 2, and we can select from the bronze view here. As you can see, we have the data, and now if we do an explain plan, you will see the location, the post filters greater than 2 is not null, etc, etc. So we can use this explain plan to see what is happening behind the scenes. Then we have materialized views here. Rather than casting the results to a view for quick access, results are stored in Delta Lake for efficient deserialization. Gold tables refer to highly refined, generally aggregated views of the data persisted to the data lake. These tables are intended to drive core business logic, dashboards, and applications. So here is how we can create a materialized view, right? Create materialized view, mat view as select device ID. We perform a minimum, mean, and average, etc., group by device ID. But here, as you can see lately, it says that we have to use delta live tables in order to create a materialized view, right? Because materialized view is one of the main data sets for delta live tables. So you can do that, or you can actually just use structure streaming to read the data here from the bronze layer and save it into the temporary view. Right here we use read stream. This is the the key here, dot read stream. We stream the data from the bronze layer and we create a temporary view, and based on this temporary view we can actually write into a final table which would be a materialized view. Well, I have already done it, so let me change the checkpoint location and it should run fine. So here for the final data frame we select from this temporary view using the select query we want, which was this one up here, right? So we use that, and then we write the data frame with dot write stream, output mode complete. It overwrites everything, available now or once, it doesn't matter, and the table is the final table. And here this one, the final table, is now a materialized view. This is another way to use structure streaming to create materialized views, because now if you don't want to use delta live tables, you can do that. Read stream, create a temporary view, just use your select query and then save the data frame using dot write stream, etc. This is it for today, guys. I believe we have covered most of the things before, but practice makes perfect, as they say. Hope you enjoyed the video. I will upload the notebook on GitHub as always if you want to have a look. Please click the like button, subscribe to the channel, leave a comment, and I will see you in the next one. Thank you.